So, now first we start with the synthesis of aldehydes. These are the general methods to synthesize aldehydes. First method is by oxidation of primary alcohols by using PCC. PCC is nothing but pyridinium chlorochromate, and the second method is by reduction of esters and acid chlorides. Esters as well as acid chlorides are the derivatives of the carboxylic acids. These esters and acid chlorides on treatment with Dibal H, that is diisobutyl aluminium hydride, followed by the protonation, and the second one is acid chloride, that is treatment with lithium tritertiary butoxy aluminium hydride, followed by the water to get the aldehydes. And the third one as well as the most important method is hydroboration as well as oxidation. And the next we will move on to the synthesis of ketones. These are also the general methods to prepare the ketones. First one is by oxidation of secondary alcohols with chromium reagents. Second one is by reaction of acid chlorides with alkyl cuprates, and the third one is the Friedel-Crafts acylation, and the fourth one is hydration of alkynes. First we will start with the preparation of aldehydes, that is the first preparation is oxidation of alcohols. Oxidation occurs by replacing the carbon hydrogen bonds on the carbon bearing the OH group by CO bonds. So, here it is the oxidation means the addition of oxygen or the removal of hydrogen, or we can also say that the increasing in the number of carbon oxygen bonds or decreasing in the number of carbon hydrogen bond. That means the oxidation mainly depends upon the nature of alcohols we are using as well as the nature of reagents we are using over here, whether it is a primary alcohol or secondary alcohol or tertiary alcohols, or we can say that what type of oxidizing reagents we are using. And these are the sum of the selective as well as the non-selective oxidizing agents. The first one is the chromium oxide, and the second one is the pyridinium chlorochromate, and the third one is the potassium permanganate. And the remaining also I have given these examples: osmium tetroxide, silver oxide, hydrogen peroxide and peroxyestic acids. That means oxidizing agents basically classified into two categories, that is the reagents which contains oxygen-oxygen bond, and the reagents contains oxygen as well as the metal bonds. So, chromium, potassium permanganate will comes under the oxygen metal bond, or pyridinium chlorochromate is also comes under the metal oxygen bond, whereas this H2O2, that is a hydrogen peroxide, and peroxyestic acids comes under the category of oxygen-oxygen bonds. Here we are using that selective as well as non-selective oxidizing agents. It means that some oxidizing agents will use only up to the aldehyde stage from alcohols, and some other oxidizing agents are using for the extension to the aldehydes, that is up to the carboxylic acids. And basically these are the main important characteristic features of the oxidation, that is when an alcohol is oxidizes, hydrogen is lost in the form of water and the carbon forms a double bond to the oxygen atom. Oxidation occurs when carbon loses electrons by forming bonds to oxygen and loss of a hydrogen. And the third one is the product formed depends upon the number of hydrogens the alcohol contain. So, now we will take the example of the general reaction, that is the primary alcohols. In starting there is only one carbon oxygen bond which on oxidation gives rise to aldehydes which contain two carbon oxygen bonds, which on further oxidation gives rise to carboxylic acid which contains 3 carbon oxygen bonds. And now we will see the basic mechanism of the oxidation of primary alcohols. Here I want to show you the example of chromium oxide. So, here the primary alcohol, the lone pair of electrons on oxygen atom which acts as a nucleophile attacks on the electrophilic chromium atom in the first step with the formation of the protonated chromium complex, which on further loses a proton gives rise to a chromate ester. This chromate ester finally loses a proton here and then with the formation of aldehyde. So, these are the steps, that is the nucleophilic attack of the alcohol on the electrophilic metal, that is the chromium, and the second one is the formation of the chromate ester by transfer of a proton, and the third one is base either it is water or it is a starting alcohol acts as a base which removes a proton. And one more thing here I want to emphasize is primary alcohols oxidize to aldehydes under mild conditions using pyridinium chlorochromate in the presence of methylene chloride. So, this is the example reaction of the oxidation of primary alcohols with pyridinium chlorochromate, and the second one is with the potassium dichromate, that is the primary alcohols oxidize to carboxylic acid under harsher reaction conditions with sodium dichromate or potassium dichromate or chromium oxide in the presence of water as well as the sulfuric acid. And this is the mechanism, that is the oxidation of primary alcohols to aldehydes, that is whatever we have seen in the previous slides, those are the 3 steps includes, gives rise to aldehyde. And further oxidation, that is the addition of water to form a hydrate. This is most important step to understand the mechanism of oxidation, because if you want to stop the reaction up to the aldehyde stage, we required milder oxidizing agents, that is pyridinium chlorochromate in methylene chloride, or if you want to continue up to the carboxylic acid stage, we can use the remaining potassium dichromate or potassium permanganate or sodium dichromate, and here the oxidation of hydrate to the carboxylic acid in the last step. Secondary alcohols on oxidation gives ketones, which on further oxidation gives acids. And tertiary alcohols, even though it does not contain any alpha hydrogens, it undergoes oxidation with acidic oxidizing agents, gives ketones. Here the oxidizing agents which are in the presence of acid, first it will converts the tertiary alcohols into alkenes, which on further oxidation gives rise to epoxides, which on further oxidation gives rise to ketones.